Hi y'all. Okay, we've got a quotient rule. Now we just need to practice using it. So kind of the same routine we've been getting into. We learn a new shortcut, we practice with it, and you really work to memorize it. First example here, we have r of z equals 3 to the z over z to the fourth plus 1. So we're going to just start right in with our quotient rule, but do be thinking as you work on these about simplification. We get some problems that you have to do quite a bit of simplification on. So always be working on that after you do your quotient rule. Okay, so r prime of z, we want, let's see here, the bottom times the derivative of the top. So that's going to be a 3 to the z times the natural log of 3. And then we need to subtract off the top, 3 to the z, times the derivative of the bottom. So the derivative of z to the fourth plus 1 is 4z cubed plus 0, but we don't really need to write a plus 0. And that's all over the denominator squared. So some things that you can potentially watch for to make sure you got it set up right. The bottom and this very first thing in the top should match up, so you can start just by filling those blanks in. Just like with the product rule, you're always multiplying one of the original functions by the other function's derivative. It does matter because this is a subtraction. It does matter which comes first and which comes second, so make sure you know that. And then, like I said, from here, we often need to do a little bit of simplify. And I think, let's look at it. Here, it might just be multiplying things out. One thing you're going to be looking for is that you have a fraction. So if you think there's any chance of factoring z to the fourth plus 1 out of the top and canceling it, you should do it. But I don't see that happening here. I have a z to fourth plus 1 in the first term, but there's the minus that splits this in two, and there is no z to the fourth plus 1 in the second term. So instead, I think in this one, I'm just going to distribute through, and then over here for the second term, you don't have to distribute, there's no addition, so just I might rearrange a little, but that's about it. So I will have a z to the fourth times 3 to the z times natural log of 3, plus a 3 to the z times natural log of 3 minus, and you can kind of pick your favorite order here. I think I'm going to put the constant, the 4, out in front, and then z cubed times 3 to the z. But you definitely have other choices for order. And then z to the fourth plus 1 squared, and I think that's about as far as I'm getting with this one. So that's just fine, but do always check it. In particular, if the exponential function was in the bottom, you'll for sure get to cancel some stuff out. Okay, so that's example 1. If you're feeling like you're getting it, pause, try these on your own, come back and check. The next one has some trig functions, and it looks like I'm missing a v. So v of t is sine t over cosine t plus t squared. V prime of t, the big operation is definitely division, so the quotient rule applies. So we're going to put the bottom squared in first this time, and then on the top, we'll start with the bottom, and that should get multiplied by the derivative of the top. The derivative of sine is cosine, and then we have minus the top times the derivative of the bottom. So now we do the derivative of cosine, which is minus sine, but I'm not just going to move that all the way out in front of the first sign and change it to plus, because I have some parentheses that I need to be careful with. So sine t, and then the derivative of t squared is 2t. So that is my entire numerator. Okay, so once again, if you think you're going to be able to factor out a cosine t plus t squared, do it. Avoid the temptation to try and cancel this pair out. You cannot cancel out of subtraction, and the top of this thing is definitely one big subtraction problem. So division does not undo subtraction. Okay, so instead, excuse me, I will multiply through these parentheses. So I get a cosine squared t plus a t squared cosine t, and then I get a plus sine squared t, and then a minus 2t sine t. I would not multiply out the denominator. It's in a fully factored form. It doesn't have that weird mix where it's like partially factored, but the big operation is still plus or minus. Hold on, what do I have written backwards here? Oh, I'm missing a square. There we go. Okay. One nice thing happened in the top. I got a cosine squared plus sine squared. So those can be replaced with a 1. So when I'm all done, and I think this probably is as far as I'll get, I have 1 plus t squared cosine t minus 2t sine t all over cosine t plus t squared squared. Okay, and I don't think I see anything else, so I'm going to stick with my original thought. I think that is my final answer for this one. All right, next is, let me zoom a little bit. We are supposed to find the slope of the tangent line to a rational function. So this one looks like it might be a little messy on the derivative finding. So r prime of x, this is definitely a quotient, so I can definitely use a quotient rule. I want the bottom, which is x squared minus 9, times the derivative of the top. The derivative of the top is 2x minus 2. And then there's a minus next, and we need the top, x squared minus 2x minus 8, times the derivative of the bottom, which is just 2x. That's kind of a nice one. And then that should all go over the bottom squared. And that's a big old mess. Let's see if we can do anything to simplify. So the first set of parentheses here, I'm going to FOIL that out. So I see a 2x cubed minus 2x squared from the outside minus 18x from the inside plus 18 from the last. After the minus sign, I'm thinking distribute in, but be careful, you want to distribute in the minus and the 2x. So I'm distributing in a negative 2x, and that's going to give me a negative 2x cubed, and then it will become a plus 4x squared and a plus 16x. That's all over x squared minus 9 squared. Okay, I'm going to point out now that this question is really just asking for the slope of the tangent line. So you could technically work on plugging in a 0 sooner, but I want you to see the simplification work because that's often the hardest part. So I want to make sure I have plenty of examples. Some nice things, at least one nice thing happens here. The 2x cubes drop out. So I end up with negative 2x squared plus 4x squared, which is just 2x squared. And then I end up with negative 18x plus 16x. So that's a negative 2x. And then my constant is just that plus 18. And that actually looks kind of promising for maybe getting to try to factor. I can at least factor out a 2. I do notice on the bottom that I could factor inside those parentheses. X plus 3, x minus 3, all squared. So if I could factor the top so that I have an x plus 3 or an x minus 3, I'd be in good shape. So let me factor out that 2 and check again. X squared minus x plus 9. And actually, now that I'm in there, I don't think I get to do anything. So just so you can see how this would work, this would become an x plus 3 squared, x minus 3 squared on the bottom. So again, if you could get a factor of x plus 3 or x minus 3 on the top, you could cancel. Here's my issue. The only factors I have here are 3 and 3 or 9 and 1. And there is no way that I'm going to get a 3 and a 3 or a 9 and a 1 to add or subtract to the negative one I need in the middle. So I actually got stuck, but do check for it because sometimes they'll simplify. So instead, I'm going to evaluate at x equals 0, which really we could have done earlier on to see where we ended up. And when I do that, that vertical bar, by the way, we use that a lot in Calc 2, so that's another way to say evaluate at. So the 2 is left over. I have 0 minus 0 plus 9. So 2 times 9. And then in the bottom, I have a 3 squared, which is 9, times a negative 3 squared, which is also 9. So I'm going to cancel out a 9, and I get that the slope of my tangent line is 2/9. So again, when you're working on your homework, feel free to go in right up here at the top and plug in x equals 0. But if you're not just plugging in a number, make sure you're simplifying. All right, one last problem in this chunk of examples. I need to zoom out a little bit more even. There we go. When a camera flashes, the intensity of light seen by the eye is given by I of t equals 100t over e to the t, where I is measured in candles and t is the length of the flash measured in milliseconds. So t is how long the flash is. We want to find I prime of 2 and include units, so we want to kind of make sense of what our I prime means. Okay, so I prime, this is definitely a quotient, so quotient rule is great. We're going to have an e to the t squared. The rule is if you have a power and then you raise the whole thing to another power, you multiply. So you could rewrite that as an e to the 2t if you would like. On the top, we get the bottom, e to the t, times the derivative of the top, which is just 100, minus the top, 100t, times the derivative of the bottom, which is just e to the t. This is a great example. Here we had the exponential in the bottom. We can factor the e to the t out of the top. In fact, if we want to, we could factor 100 e to the t out. The e to the t is really important because I'm going to cancel it. But while we're factoring, we can absolutely take the 100 as well. We are left with 1 minus t in the parentheses. And then in the bottom, we have e to the t squared, or e to the 2t. And what happens is you get to cancel one of those e to the t's out. So when we're all done, it's 100 times 1 minus t over e to the t. So that simplifies really nicely. So watch for those things to happen. We really wanted I prime of 2. So we want 100 times 1 minus 2, which is negative 1. So that will be a negative 100. And then divided by e squared. Since this is a word problem, I think it's great to convert that to a decimal so that we can kind of try and make sense of our answer. I got roughly 13.53, and we are supposed to include units, which for my purposes is so that I know that you made sense of what your answer means. So if we think about this function, it's inputting t values, which is the length of the flash measured in milliseconds, and we're outputting the intensity of light measured in candles. So this is telling you how fast the intensity is increasing as the duration of the flash increases. So this is candles per millisecond. So that should give you some of the variety again and just seeing the quotient rule in the mix of these same types of problems we've been doing.